Hello, my name is Aldi Sumaputra, and today I'm going to present about my internship report, which is Operational Uplink and MA Transvision. So the objectives is being able to understand the working of uplink satellite, adding more insight, knowledge, and new experience from professionals, able to implement theory and knowledge from the university, and to fulfill the academic requirement for the internship course. The internship location is in PT Transvision, Tangerang, Banten, Indonesia. The internship began from 15th February to 30th March 2021. So the company general profile, Transvision is a transmedia company that works in the field of providing subscription television with its main office located in Jakarta, Indonesia. It started broadcasting from Telkom 1 satellite in C-band and Measat 3B at Ku-band starting from 2016. So slight history, they began from Telkom Vision, which started in 2006. In 2006, they started a new paid TV service, and then they launched Gruvia TV in 2011, and then in 2013, Transvision was born in hopes that it would be the leading company in paid TV. So the company has visions and missions. Vision to be the leader in subscription TV market that prioritizes excellent service and become the choice of Indonesian families. Their mission is providing excellent integrated services, providing the best quality viewing services, and be at the forefront of innovation and excel in the face of competition. So these are the facilities that I may use or they had in the place that I worked. So there's the battery room, the cubicle and transvision room, transformer room, KPA, genset MDP room, and then the meeting room, and etc. So this is the electrical and uplink system of Transvision Satellite's master control station. So the electrical system starts from the PLN, which is their main power supply. They use the middle voltage, which is 24 kilovolts from the PLN cubicle into the transmission cubicle. Then it is streamed to the transformer. The transformer that is used is a step-down transformer. The voltage is lower to low voltage at 380 to 400 volts. Then the voltage enters the ATS AMF panel and then the MDP panel. In the ATS AMF, the PLN power supply and the backup generator are connected interlocked to the motorized choice. If anything happens to the main power system, or if the PLN electricity is out, then the choice will immediately switch to the backup generator. It takes 5 seconds for the backup generator to warm up and synchronize the frequency to 50 Hertz. And the cubicle is basically a safety for the voltage because the system is in 3-phase. So when the electricity incoming is maybe too big, they might trip. So the cubicle will anticipate it and maybe short circuit it or discard it. Then the transformer, as I said before, the transformer we use is a step-down transformer, which steps down the 24 kilovolts that we get from the panel, from the PLN to a low volt, which is 400 volts. Then the backup generator, the genset that Transvision use is Hardtech HT 300cc silent type brand genset with the capacity of 300 kilovolt ampere to distribute the load to the uplink devices with the consumption of 51 liters an hour at 75% and 68 liters an hour at 100%. So as I said before, if the power from the PLN goes out, the choice will switch the power to the genset and it will take 5 seconds to warm up and synchronize and 1.5 minutes to cool down when it is turned off. So this is the ATS and AMF panel, which is the main power in a way. So they have the circuit breaker. So you may notice there are two circuit breakers. for backup, for PLN and genset. So then the choose motorized and manual. So they have two choice. The motorized is basically an automated version, and the manual is you manually use the lever to change to the genset. And the MDP, main distribution panel, is used to distribute the power to essential and non-essential appliances. In this satellite control facility, the distribution of electricity is divided into essential and non-essential. The electricity from the MDP is connected to the UPS, from the UPS to the DB UPS, which distributes the electricity to essential and non-essential appliances. So this is the essential and non-essential appliances. Essentials is basically uplink appliances like antennas, KPAs, which we'll get to later, servers and monitoring systems. The non-essentials are panel lighting and utility, which controls all the lighting in the facility. And the DBAC, well, it basically controls the AC in the area, in the rooms. And then timer lighting, which is a timer which turns on the lights in the antenna when it reaches 5 p.m. So this is the one of the UPS controls or modules in a way. So basically the UPS gets its input from the MDP, and then it reaches to the rectifier, and then it converts from AC to DC. It charges the battery and then goes back to the inverter, and then it converts back to AC, and then its output is put into the PDB UPS. So it charges the batteries. So when the CHOS switches to the genset has 5 seconds to warm up. So in that 5-second interval, the battery will discharge and give power to the facility so that nothing actually stops. But if there is a problem in the DB UPS or from the input, the UPS will bypass so that it doesn't charge the battery or gives power to anything. Next is the uplink system. So this is the basic circuitry or connections between the uplink devices. It starts from the modulator, which gives the data to the def switch in the form of L-band frequency. And then the def switch gives the input to the UPC. The UPC then holds the power from the modulator for when there is an attenuation. Then from the UPC, it goes to the KPA, klystron power amplifier, and it is used to convert L-band signal into KU band. From the KPA, it goes to the switchboard, and then the switchboard goes to the antenna. Next, so the modulator in transmission is used to convert the analog signal from the multiplexer into a digital signal. The frequency of the modulator is a low frequency at L-band. The modulator then determines the type of modulation, which roll-off value that can impact the number of sent data. This is the modulator specifications. So then the UPC. The UPC is a device that is used to control the output power in case there is an attenuation caused by rain or sun outage. The UPC controls the KPA and the modulator output. The power from both devices is stored in the UPC, and if there is an attenuation such as rain, then the UPC will increase or decrease the power of the KPA to keep the performance of the service operational. The UPC device works based on the signal level received by the DTR device and where the DTR device receives the signal from the satellite beacon via 6.3 meters of antenna. The KPA, klystron power amplifier, is a system that uses vacuum tube concept and the electron bunching concept to amplify microwave frequencies that achieve high stages of power gain. It is used to convert L-band L-band signal from the modulator to uplink signal using a local oscillator. Also to increase the power of the frequency so that it can reach the satellite. Currently, the product KPA PT Transvision is CPI. So these are the basic activities that I do all day. So checklist MA, checklist uplink, and measuring KWH per day. There are some that I did not put, such as, well, helping cleaning the antenna or mopping the KPA room. So the MA checklist, it is comprised of many. So I will just skim over it. The ATS AMF, the MDP, the sub MDP, the PDB UPS, AC in the RF room, the PDB charge control access system. So you can see from these, they are basically the same, which is just checking the phase-to-phase voltage, the currents, the frequency cost, the RST for each phase. So the differences, well, in the AC, well, we check the AC, the temperature, so the temperature doesn't get too high or gets too low, so there won't be any condensation. And you can see that the AC switches off between two units, so the AC won't get broken if one just continuously goes on. So for the uplink checklist, we don't actually do all of them. They didn't tell us, or they said just do these. So first is the temperatures in the humidity in RF and plenum room. And so we check the RF room is basically the shelter or where we keep the KPAs, and the plenum room is the battery room, which I said before. Each room has to be cooled or keep at an average temperature of around, for the RF is around 18 for the temperature, and the plenum room is around 30 degrees. So that is the optimal temperature, so that there won't be any condensation, so the water won't, how do you say it, interfere with the appliances. So this is the KPA2, another of the uplink checklist. So we check for its temperature and power output. So each KPA has its own antenna in a way. This is the KPA2 vertical, if I'm not mistaken. So its usual power is around below 60, so about 59 max, and its temperature is basically around 20, 21, 22. And then there is measuring KWH per day. So they keep tabs on how much electricity that they actually use per day, and then they calculate it, so it matches the bills from PLN. So the formula is basically LWBP, which is luar waktu beban puncak, times factor meter times LWBP rates plus WBP, waktu beban puncak difference, and factor meter times WBP rate. Conclusion: Transvision Satellite Master Control Station holds one of the most important part of the broadcasting system, so every appliance should always be checked and maintained with the utmost care possible, be it just checking the output and values of the appliances to cleaning the antennas and mopping up the rooms. Suggestion: the author recommends employees at Transvision Satellite Master Control Station to map out their circuitry for the servers and other electrical appliances using ETAP or Dixilent apps for an easier time to search for which cable goes to where and test any new system that they may want to implement in the future. Thank you for your time. My name is Aldi Sumaputra.